Yeah, good afternoon, everyone. So let's start our workshop with Vande Mataram and Saraswati Vandana.
Vande Mataram, Vande Mataram, Sujalam Suphalam Malayaj Sheetalam Sasya Shyamalam Mataram, Vande Mataram, Shubhrajyotsna Pulakitayamini Pullakusumita Drumadala Shobhini Suhasini Sumadhura Bhashini Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणा वरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवै सदा पूजिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापः
Yeah, very good afternoon, everyone. I, Dr. Shrija, on behalf of IIIT Sri City, welcome you all to the two-day workshop on data science trends and career building. And today is the second day of the workshop, and we have three eminent speakers with us. First, Mr. Abhishek Sanwalia from Microsoft, and Mr. Derek Jose from Futura Decision Sciences and Analytics, and third, Ms. Supriya Raman from JP Morgan and Chase. Let me introduce Mr. Abhishek. I'll give a brief intro. Just a minute. Yeah. Mr. Abhishek has 13 plus years of experience in data science, comprising NLP, NLU, optimization, computer vision, and recommendation system implementation at scale. Currently, he is working as a principal data scientist at Microsoft with key priority to deliver industry solutions focused on ML-based implementations to drive sales, growth, and cloud consumption for Microsoft Enterprise Business. As founding team member of Advanced Analytics and AI COEs, he has contributed at core by setting up and benchmark data science practice at Mars, Visa in merchant domain, Fidelity Investments, Dell Global Analytics in social media domain, and Genpact in NLP solutions. Delivered ML, AI, and analytical solutions for diversified domains like financial services, retail, logistics, and payment network. He is a recipient of distinguished 40 under 40 data scientist in India 2021. As an active ML researcher, he has authored 5 international research publications, and he has filed 6 patents and 3 trade secrets. Mr. Abhishek has done his master's from IIT Kanpur with specialization in machine learning and NLP. He has mentored more than 1,000 plus data science aspirants through online, offline data science programs conducted by Great Learning, BITS, WLP, corporate L&D partners, etc. Once again, we welcome Mr. Abhishek. Over to you. Over to you.
Yeah, thanks, Dr. Srija. Can I share my screen?
Yeah, yes.
All right,
Just
and sure. Yeah, just wanted to confirm if my screen is visible to everyone.
Yes, it's visible.
Perfect. All right. So first of all, I would like to thank respected Director Sir and Dr. Srija for reaching out and providing me great opportunity to interact with very talented folks at IIIT Sri City. So really thankful for you. And yeah, I mean, for this particular workshop, to make it more productive and to make it more intuitive, what I would like to do is, as the topic suggests, I would like to take our brightest students through the evolution that has happened in the data science area, and also how can we prepare ourselves for the future roles and different things that will be there to cater in the data science industry. So right now, in terms of learning, definitely IIIT Sri City is providing great foundation to the students. Now, as a mentor, being a veteran in the industry for 13 years, I just want to provide my view in terms of how this industry is growing, what are the different challenges that we have, how they can make a match for the skill set that, yeah, so how they can take their career ahead, how they can, bridge the gap between the skills that is needed by the industry versus what they are learning right now. So that's the whole purpose of this particular workshop. I won't spend much time on introduction. I think already Dr. Srija has done that. So I would directly come to the agenda that I have. I would like to cover in 30-35 minutes, and definitely I would like to keep last 10 minutes as an Q&A in case if anyone is having any kind of doubts or need any kind of clarifications, guidance, direction, etc. So with that, I would like to cover what is the current industry landscape, how mature is the industry in terms of data science adoption, then what is the trajectory, how so far, what are the different areas which we cover under data science when we try to deliver solution at a scale, then what kind of a skill set we are looking for right now, what is the successful metric that we can define when our whether it's like freshers joining the industry or lateral hires joining the industry, what is the expectation, how they can boost their career by acquiring those skill set. I will also try to cover what academia offers versus what industry needs and how we can make the best adoption in those skills. And definitely I will also try to throw some light on future readiness. What is the champions approach? Companies like FANG companies, be it Google, Microsoft, Meta, how teams are delivering great solution at great pace and adopting all these changes which is coming our way in the field of data science and AI. So these are the few things I would like to cover, and definitely I'll keep some time reserved for Q&A. But in case if there's anything which is lingering to your mind, please feel free to stop me and ask me in between, precisely whenever I will be switching the agenda topic by topic. So with that, I pardon in case if the font is smaller, but I just want to fit in things so that I can provide the landscape. So currently, I would like to talk about how this industry is growing. So when I will talk about 2012 and 13, when the adoption has started in the area of data science, when even this term has been coined very recently, there was a lot of buzz. This was a buzzword initially, but over the period of time in the past 10 years, definitely we see evolution to an extent where industries have make it a mainstream practice. With that, if you will see, and this particular report that I'm showing you is from McKinsey, which they have presented as a part of their state of AI in 2020. So you can see none of the areas in the industry has been left where data science practice has not been adopted as a mainstream. There's definitely a great growth marginal growth that has happened in different areas and the domain, be it marketing, sales, or be it strategy, corporate finance, supply chain, manufacturing, risk, products and the services, or be it human resources, in fact. So all these areas have, the data science growth has become massive and the integral component of it. And definitely with that, it shows us that right now the demand is not on the basis of something that companies need for, but it's definitely something that that is a must component for each of these companies if they want to stand out and if they want to serve their customer better. So every industry is actually going through that particular transformation, and that's why digital transformation is taking them to the next level. Most of the companies, most of the big players and medium players have adopted this thing. So with that, now this data science or AI is no more a buzzword, it's a need, and it's basically an integral part of the core operations that any company, any organization in this world will need, and definitely need with a, this is basically a need of our. So with that, also, as I have mentioned in the previous slide, industry is growing and it has come to the mature phase. But this is also an important thing to understand what kind of company you will be joining. So how it is important and relevant for our aspirant data scientists and the students who are in their initial years of the college, definitely they need to identify what kind of career path they need to adopt. People are joining startups, people are joining mature companies, few are joining product organization, few are joining services organization. So whenever the in future you will come across different scenarios, different companies and the offers, a person has to be in a position to evaluate what kind of maturity a particular industry or a particular company is holding with. And that's where it is really important, not only for freshers but also for experienced folks, to analyze and to identify whether this is the right career track or right career path for them. So these are the 5 major categories under which we can define these companies. Few companies are still in the learning phase, few are emerging, few are functional, few are integrated, and for few companies this has become a culture. So if I will take few examples, and please don't quote me if I have missed some company. It's just like the experience that I have so far in terms of data science. So I will give you a few, basically I would like to quote examples from my previous organization and across the industry where I came across for the consulting work. So I will start with the final one, where this data science has become a culture for the company. So companies like Microsoft, Google, Meta, definitely they can't live without that. So this is something which has become their DNA, which is a part of their DNA, and definitely they have a very mature and developed practice for data science and AI. So if you are going to join that kind of organizations in the future, definitely you do have a great career path ahead, because already there are mature practices. You will learn from the evolved practice. It's no more evolving there, and definitely that will give a big boost to your career. But unfortunately, industry, this evolution happened in the past, and not each and every vertical or each and every company or each and every industry is ready to that extent. So in that case, there are a few companies which are still good, which are offering the good proportion in terms of integrated things. So if I will talk about my previous organization like Maersk, so where it is a giant and it is one of the biggest shipping company, but this evolution and digitization has started as a need of our in just last 4 to 5 years. So they have adopted this practice and is still in a phase of integration, where they do have a dedicated team of data scientists, and they work a lot on the supply chain side of it, and they have mature IT infrastructure in place, and definitely they can take the next leap and they can move to the fifth bucket, which is like where this will become a culture of their company. So it will become a cultural in that sense. So definitely these kind of companies are on the radar, where they can definitely go and move to the set of companies where they have most mature data science practice. So you can target these kind of companies as well. Then comes the functional, where they have data science capability, but it is not having the very much IT infrastructure. What do I mean by IT infrastructure? Whenever you create any kind of model, let's say some sort of classification or some sort of forecasting model, which will help the company to forecast something or to predict something, in that case, definitely you have the capability to build the model as a data scientist, but it will not be fruitful unless and until company is having a mature infrastructure in place where you can actually provide that solution as a service or provide that solution as a product which you can scale, and which can become a USP for the company, and company can grow revenue through that. So there are companies who are in the exploratory phase, which comes under this functional funnel, functional umbrella, and definitely in this particular phase, companies are yet to go to the next level. So these kind of companies, as a beginner, if you will join, definitely you need to have acquire few skills in terms of the IT side as well. So that will dilute profiles slightly, where not only as a core data scientist you will be working on the models, but also you need to take care of few of the infrastructure requirements in terms of deploying your models or in terms of making your algorithm functionalize. So that's where this part comes. And most of the service industry, if you will see, apart from the big service players like Accenture, KPMG and all, most of the companies fall under this bracket. And then comes the second last and last part, which is learning and emerging. Few startups work in this space where they will be relying in terms of infrastructure and other things on the client, and they will be having very small data science team. I'm not saying that these companies are not good. They can grow, they can become next Microsoft or Google, but obviously there will be a huge curve that they need to follow. And in that case, definitely the adoption is not to that extent. So why I want to focus on this industry maturity, so that you can choose your career wisely once you will be in a situation or in a position after your third year and final year. Accordingly, you can determine which kind of trajectory you want. Few people uh, are okay to start with the learning emerging companies. Few folks are okay to join only big cultural companies, and few folks are okay to join functional integrated. It's a choice, it's a personal choice. But saying that, definitely we should know like how to assess the maturity level of a company when we are joining there as a data scientist. So that talks about the industry maturity. And yes, 60% of the industries have crossed this functional integrated cultural curve. So data science practice is a lot more mature as compared to the 10 years back when this has been coined and started. So this is the current status of industry. And with that, we will come to the second part of it, which is the supply part. So industry is the demand part, where industry will try to acquire these skills from students like you, and they will try to hire you, and definitely will be working on very innovative products that they want to launch in the market, or maybe current products that they have already successfully launched. So now comes the supply side of it, which is the students, which means the data science aspirants who are actually trying to make their career in this field. uh, it has also evolved to a great extent, and I will talk more from the skills perspective, and then I will give you a deeper dive into the core side of it. So initially, when in 2010 we started, there were a lot of hiccups in terms of data acquisition. Like, we were having algorithm in place, but there's no point of applying something when you don't have mature system for diversified data sources, or you don't have any particular BI layers in between. So it was really difficult. So what industry has done intelligently, they first try to focus on the lowest bottom part to make it a great foundation, so we can evolve our data science practice. And what they have done is they define the data management, data architecture, and data strategies. Now, if you will see, still in 2022 also, I can challenge, there are 40-50% of the companies where this data practices is still evolving. So as a data scientist, if company wants to get a great value of their data scientist, definitely this pillar of the data strategy has to be really strong. And companies like Microsoft, Google, definitely they have a very strong backbone for this, and they do have a very good foundation. But still, whenever you will join some company, you may surprise if there is any new initiative that we need to go from the bottom of this curve. So in order to implement a successful data science thing, definitely this data strategy, management, and architecture has to be really strong. There are folks, dedicated team who work on this side. If you will think in the world of data science, data engineering, which is even more admirable and more powerful job in the past couple of years, even there is huge demand for data engineers. That is because of the fact that you can't evolve data science practice unless and until you have a very strong foundation for data strategy and data management. So that's where this has become a key pillar. Without this, definitely you can't take next leap in the data science. Then comes the BI component of it, where you will be working more on the data exploration side. You will be involved in creating the reports, and that is the best point to start your data science journey in your career. The reason is, when you work on the BI side or the reporting side, you will try to learn the business. You will understand how business is actually interpreting different matrices for their success. So for example, if someone is into the credit risk modeling, you will try to learn what are the different matrices which defines a credit risk score, whether we can give loan to a person or not. So how credit worthy a person is. So definitely there will be some key metric on the basis of which banks or financial institutions try to give loan to a person and reject the loan. And everything has been automated nowadays, and machine learning models are running underneath. But what are those matrices? What will be the underlying data? How we are going to use it? First, we try to understand the demographics and try to understand the behavior of a person who is applying for a loan. So everything comes under this business intelligence umbrella, where we try to understand the data first. We try to explore the data. Then comes the last part, which is where you folks will be working majorly, is the data science, machine learning, and AI side of it. So once you have good understanding of the data, definitely you can take the next leap and you can work on the predictive side of it, because the previous thing, BI reporting and all, will tell what has happened. It will project everything which is historical in nature. And it is also a great thing to work on, because your key stakeholders like CXOs, CIO, CEO want to know what is happening on a day-to-day basis in the company, in terms of sales, in terms of marketing efforts, in terms of revenue growth. So they are very much relying on these reports even till now. And definitely they want the data scientists to provide them some predictive component, so they can project for the future. They can understand how future will look like. And that's where both these practices goes hand in hand, where the first part of business intelligence reporting will try to help you understand what is happening, what has happened so far. And this data science will help you to use those historical data and the events and the patterns and predict the future. So that's how this evolution has happened. And whenever you will be joining, the best place for a person to join is this second component. And there is a reason. It is not that you are joining one level below or you are going back in this cadence. No, but it is really important to understand data and business first, and then only apply your algorithm and data science on it. Then only it will give you a very stable and great career, because subject matter expertise along with your data science will make you really stand out in this world of data science. There are people who are really good in algo, but they are not really good in the applied side of it. So in that case, what happens, there will be always a gap. You will not be able to deliver business value. Whereas if you are trying to learn the business from the BI side of it, definitely it will take some time. You may come to the predictive modeling part later. Maybe you have to spend some time in the system, but definitely it will give you a very good understanding and a great foundation to make your career in the field of data science. And that's why this pathway is really important, from data management to data science. Now, I would like to cover something on the skill set side. What is there that we need when we are, so already being a computer science student, or even in the similar kind of streams that you guys will be going through or studying, you will be acquiring all these things. So algorithms, data structures, coding, a lot of stuff you will be aware of. But what will be the core thing that will make you a successful data scientist is basically an overlap of few fields. And that's really important. There are few areas which you will acquire while you will join a corporate job, or maybe when you are joining a research environment. Definitely few things you will learn over there, but there are few things for which you will be ready once you will be completing your graduation or post graduation, depending upon what program you are right now. So if you will think in terms of how we can ensure successful solution and the deliveries, few things you will acquire by your academia, where you will be having knowledge, good knowledge of algorithms, good knowledge of maybe coding, Python and different stuff that you will be using, and databases and other stuff. So IT skills and data science skill is something that you will be knowing. Only part that will be required is the skill. So obviously right now you may be working on the toy projects, but definitely they possess a lot of value, because those particular projects will be foundation for getting a good projection in the area of data science. So IT and data science skills you will be having, depending upon the curriculum that you follow. Only thing that you need to gain is the business skills when you will join the corporate, or if you are joining any research organization, definitely there also business will be replaced by the core area. Ultimately you will be solving this problem for a particular industry. So again, there will be a domain knowledge required in this particular thing. So when you have basically when you are trying to become a leader in this particular area, you need to have a balance of all these three things. Nowadays you will find that a lot of people say, no, I want to only do data science, no IT stuff, or no business skills. To be very honest, you will lose the balance in case if you are losing on any of these three. You will definitely become a successful person, and you can deliver solutions at a scale consistently only if you will maintain balance of three. You don't need to be really heavy on the IT skills, just you need to have a good understanding, because in organizations normally this IT practice will be set up separately, and they will complement your data science model or whatever you will be building. So definitely this will be covered by them, but you must be having some understanding, some overlap with them, so that you can have a better communication in terms of solution that you are going to derive, because ultimately it's a data scientist who knows what he is delivering and who is the best person to assess what will be the right IT requirement for his solution or project. Same thing happens here in the business also. You need a good overlap to understand what business I'm trying to solve, what problem is there at hand. It's not just you will get the data, you apply some method, create results, say this is the accuracy and done. No, whether it is addressing and answering the real problem, real thing that is there for the business, which matters. So you can answer only when you understand the business first, and that's where converting a business problem into an analytical problem is the most critical task of a data scientist. Most people fail in that. The reason is they either directly jump on the data science side of it, or either they are very good at business but not capable from the skill set side of it, where they can understand how I will convert this problem into a machine learning problem. So that's why both are equally important. And the third part is also, when you will try to deliver a solution, you definitely need to know what will be the infrastructure needed. So some sort of IT skills are also mandatory to possess with. So when you are trying to take next leap in your career, guys, definitely you need to have a good understanding of it. This business skills you will keep on sharpening depending upon the area, industry and the vertical that you are going to join. But remaining two aspects, I would definitely suggest that whatever coursework and the course structure that has been defined for you is more than sufficient to gain knowledge about these, and this will definitely go to the next level when you will join the industry. So that's about how you can ensure a balanced profile for your data scientist, and how you can deliver best in the industry when you will be joining. If you will keep this thing in your mind, definitely it will take you to the next level. With that, guys, I would like to take a pause before I will jump to the two topics where I will throw light on how you can bridge the gap, what industry needs and what you need. If there are any questions, I would like to welcome. And in case if you want to park them at the end of the session, that is also fine. So any questions, anything that you want to ask at this point of time? All right, no problem. So maybe we can park it at the end. So the next thing is where we are and where we want to take our career and where we want to take the next leap. So guys, right now in terms of knowledge, if you will see, I'm part of different different kind of content structuring and basically the course curriculum that we define for industry, for corporate trainings, as well as for some institutions. So I'm well aware that nowadays this has picked to an extent where students are acquired with most of this stuff. Machine learning, some sort of data visualization, statistics, probability. Anyways, this was a core area from the beginning. Nowadays, deep learning kind of stuff has also been introduced in few of the courses, maybe in the advanced years, third year or final year, depending upon the course curriculum. So already students are learning all those core things that we definitely need. So universities are offering, and students are learning that thing, and that is exactly what enterprise is looking for. But if you will look from an overall perspective, it is like 40-50% what industry needs. So deep learning kind of stuff and your machine learning is definitely there, but there are few more things that we, and whenever we try to make our career in data science, we sideline few of them. One of them is definitely big data management, because without that you cannot deliver solutions. One is the engineering skills. A person has to be really good in terms of understanding the cloud computing and understanding how we can deploy different kind of services, different kind of APIs and all. So basic understanding will definitely be required. So it's not that once the curriculum that has been designed by the universities and our academia is sufficient. Yes, that is sufficient, but that will cover only 40-50% aspect. Remaining things definitely you can earn when you are doing your capstone projects. You should try to deploy all these things like engineering skills, advanced mathematical models that are there, or maybe you can just take one particular thing and get a deeper understanding of it. If you are working on a particular project, that is the time when you will try to get more deeper for this. And also think in terms of how you are going to scale. Suppose right now you have implemented it for one particular domain. How if I will ask you to do it for, let's say, multiple states or country? So obviously that is the key aspect where we need big data management. So that's where, yeah, again, it is coming from the McKinsey report, where different respondents have advised that, okay, what would be the right proportion and right need for it. So you will see machine learning engineering skills, definitely 25-26% respondents have seen that, okay, this is something critical. But without big data management, advanced mathematics and deep learning, industry is in a phase where you can't take it to the next level. Surprisingly, deep learning in 2020 has surpassed the machine learning, because nowadays, obviously, in the computer vision, audio, video, there are a lot of things that is happening where the conventional ways or the traditional methods are not able to serve this thing, and that's the reason it has come up in this. Now, how is this applicable in terms of industry when you are applying it to the industry? So what roadblocks do you face when you want to basically enable your solution? So one thing is having the knowledge, second thing is applying that knowledge, third thing is where company or your organization is going to get that value from that knowledge and monetize it. So when they monetize it, they want to monetize it, definitely they want to push into the production. What does that mean? They want to sell it, through a channel, and definitely it should be scalable. So if you will see, unfortunately, so far in the industry, only 20-30% of the models that has been prepared by data scientists, they go live or they go into production. Means companies can make money or they can utilize these models for their decision making only. Whatever have been produced in a year, only 20-30% of it has been utilized by the companies. So what happens to the remaining 70%? The remaining 70% has gone through the different kind of roadblocks. You may have come up with a very advanced model, but there is no point of that model or decision making mechanism unless you can deploy it or unless you can productionize it. So along with your machine learning skills, definitely in the industry when you will go, you need to understand how we need to set up the production environment. And right now, one hot area in the data science field is MLOps. So earlier we used to have, in the software engineering jobs, we used to have this concept where DevOps was there, which has been taken care by the software engineers, and then there will be some core person writing the algorithms and the code for that. Same thing if I will apply here in the data science, the data scientist will be developing the model, but it will not make sense unless and until this will go to the production cycle, or it will become a mainstream product for a company. So that's why ML ops is really hot nowadays, and going forward, that is another mature practice that will be having a lot of requirement in the market. Even right now, if you will go on the LinkedIn and find the job and the areas where companies are really hunting for this kind of talent is the ML ops, because they know without ML ops person you can't deliver, you can't push your model into production. So definitely industry adoption wise, ML practice need to be mature in terms of getting all these things, and that's why Docker, Kubernetes, or some standard IT implementation, your coding in Python packages and all these things are fine. Anyways, we have gone to that level, but definitely these are the few skill gaps that we need when we want to really make our practice mature. So data scientists were taking care of these things, but nowadays this ML ops is actually trying to bring the positions where data science plus some sort of development activities has to be taken care by a single person. Now the final slide, and after that I'll open to the questions. Sorry if I have exceeded some time, so maybe I'll spend a couple of minutes here. So what are, we will look all these perspectives that we have seen so far, where industry is heading, what is the key what are the different key roles that we are having, what is the skill set that we have acquired, where we need to take our career. Now I will talk about what standard practice has been adopted by the companies which are having mature practice. So here if you will see, and again this came from a survey from McKinsey, so you'll see there are three major pillars for each organization or a company if they want to deliver successful machine learning results or solutions or the products. So the one thing is the tools and the technology, model tools and technology. So what these mature companies like Microsoft, Facebook, Google have done, they have evolved their systems to such an extent that they have standardized these processes, and they do have a toolkit for everything. Suppose if I want to work on a forecasting, you don't need to go and create your code repository for that. There will be some standard practice around it, available models around it, packages around it. There is continuous research that is happening in that area where they will be keep on updating these packages and all, and their data scientists try to adopt these standardized practice. So models, tools, and technology is the biggest pillar, and wherever high performer companies are there, they definitely rely on that as compared to the other companies which are not really great on that aspect. So definitely mature practice basically considers models, tools, and technology as the key part of their data science strategy. The second part is data. This is the area where even we, most of the companies are saying we have data in terabytes, petabytes, but they are not able to gain value out of it. The reason is they do have data, but they don't know how to bring it to the data lake or how to bring it to a unified form where they can put some sort of data science models on top of it. So definitely having a mature data practice is something which these organizations like Microsoft, Google has identified is one of the key pillar. And they, whenever they start working on any of the vertical or problem or domain, they first strengthen their data practice. The third part is the adoption. So whenever they create a solution, they always think holistically. It's not that only this will solve one part of the problem or one particular thing. They try to think it in terms of product, basically monetizing this product across different industries. So suppose if Microsoft is selling some particular product, it is not that it is domain specific that they can sell for healthcare or they can sell for only supply chain. They will think in terms of how we can make this as a global product. If you have used Teams, that is a global product. If you have used Office, that is a global product. And definitely the intelligence that they are bringing it through the data science and AI side of it. So whatever implementations or adoption they are thinking in terms of a global value rather than solving a one particular specific thing. So they take more generalized approach in it. So that's all about the future readiness, where the champions approach says having these three key pillars in their strategy will definitely help them to shape great products. And if you are making your career, definitely these are the key pillars for you as well to master. With that, guys, I would like to stop the presentation, and definitely I'm open for questions. Sorry if I have exceeded the time, but I won't mind spending 5 extra minutes if I am allowed to do that. So yeah, over to you.
Okay, Thank you, Mr. Abhishek. Okay, actually, it gave a clear idea like what data strategy is, what BI is, and what data science is, and what role the fresher should choose. Okay, and it also gave an idea on the skill sets. What are all the skill sets required for a data science roles? And there are few questions from the student side. I'll just put the questions.
Please.
So, how to get internships in the field of data science and machine learning, and what should I do to make my CV attractive?
Great. So I think the second part of the question I have already addressed. If you are acquiring these skills in terms of algorithms and the Python, how you can make your CV attractive, you just acquire these skills, acquire some data engineering skills, acquire some data science skills like your different models, and acquire some skills around the coding. So that these are the three main things that companies look for. To address your first question, how can I get internship? So nowadays, if you will see, even whether it's like with a big company or a smaller organization, all having their internship program, and they rigorously work with that. So either you can tap your alumni network, or you can just float your resume. Even over the LinkedIn, you will find a lot of channels. So if I will get time, I will definitely float. Even in Microsoft, if I will talk about my current organization, we do have internship program, very rigorous internship program. So they even, I mean, if you want to apply, you just go on the website and apply. It's all about the awareness that you need. And a lot of companies encourage that because, interns work hard, and this is the first exposure for them, so they try to give their best, and at the same time you will be able to get your hands-on experience in that area. I hope that answers your question.
Yes, Mr. Abhishek. One more question I have. On listening to your talk, I came to know that data science is a good career choice option. So what should I do to become an industry-focused data scientist?
Very good question. In fact, we need to take that approach, because if you will try to cut across different industries, you will never get the expertise. Because see, as a skill, if you will be working only on your data science skill, it will not make you a great data scientist. But if you will acquire the business acumen along with this thing, you are irreplaceable in the industry. So definitely you should take the industry focused approach. You first see what is that particular industry which really attracts you, because that will be a gradual transition for you. Suppose if I mean, the simplest example is Amazon. We all are consumers of Amazon. We do this online shopping and everything. You can start your career with any sort of e-commerce company, where if you are interested in that kind of, because eventually you will be able to learn, and with a gradual thing you will be able to learn this thing without putting much effort, because that is your area of interest. Second thing is, if you are interested into products, you can take companies like Microsoft, LinkedIn, Google, Facebook. They are product specific companies. If you're interested into the platforms, you can choose companies like Databricks and all, which are working heavily on the platform side of it to supplement and to augment the data science practice, where they will be having their clusters, they will be scaling it, and they will be having a lot of ML platform related stuff. So depending upon what is your orientation, what is your area of interest and expertise that you think you can qualify for, you can choose your career path. But yes, choose a dedicated career path, excel in that. So once you will be excel in one area, definitely it will not be difficult for you to replicate your success in the near future.
Thank you, Mr. Abhishek. And we have our director with us. Good evening, sir.
Good evening,
sir.
Abhishek. Thank you for joining. I couldn't join at the beginning of the session, but I was listening to your presentation. Thank you for sparing your time, and we will look forward to work with you.
Sure, sir. It's my pleasure to
have you again.
Thank you, sir. It's my pleasure to cater your workshop, and definitely a great initiative. And in near future also, I mean, wherever you need, because this is the time when I can again contribute back to the community from where I have gained and I have become a successful data scientist. So I would love to do that part. So thank you very much for the opportunity.
Thank you so much. Yes, thank you so much.
Thank you, Mr. Abhishek.
We'll meet again.
Yeah, thank you.
So Mr. Derek has come.
Yeah, sir. We will start now.
Hello, Derek.
He joined and I made him as co-host. Hello? Yeah, you can try now, sir. Yes. Okay.
So you joined?
Yeah.
Yes,
can
sir,
you
he
hear me?
joined.
Yeah. Hello, Derek. How are you?
Oh, hi. Good evening,
Yeah, yeah.
Professor. How are you?
Yeah, fine. Yeah.
Can you hear me loud and clear?
Yes. Thank you so much for joining. And I'm sure that students will have a good session today with you.
Sure.
Okay.
Srija, you can take over from here.
Yeah,
Sure.
okay, sir. Thank you. Thank you so much. Yeah, good evening, Mr. Eric. I'll just give you a brief introduction about you. Yeah, so we have a fifth expert with us, Mr. Derek Jose. So Mr. Derek Jose is the co-founder of Futera Decision Sciences and Analytics. He is also a visiting faculty at the Hasso-Plattner Institute of Design at Stanford. Prior to starting Futera, Mr. Jose served as a vice president in Mindtree Limited for 10 years. He worked for around 5 years as a customer intelligence solution architect for AT&T's in New Jersey. He started his career as a software engineer in Thermax Limited in 1990 and moved to Fujitsu in 1992. He is an organizing committee member of Industrial AI Consortium Deep Tech Community of Bloom Ventures. Along with that, Mr. Jose is also serving as a vice chair of the IEEE Global Industrial AI Standards Committee. Let me also talk about the company, Futera. So Futera's battle-tested industrial AI apps guarantee balance sheet outcomes for energy, manufacturing, and engineering industries by embedding them into the heart of industrial operations. Futera is trusted by Shell, Technip FMC, Lupin, Hess Henkel, GTT, and ABB corporates. Cerebra, their industrial AI product, is deployed in more than 20 countries, unlocking $300 million in impact till date and counting. Yeah, over to you, sir.
Thank you, ma'am. And good evening to all of you. Let me bring up my presentation. Has it come up?
Yeah, it has come up. Yes, you can go to full screen mode.
Sure. Yeah, let me do that. Okay.
Yes.
Better? Okay.
Yeah.
So what I'll do in the next 15-20 minutes is quickly give you a glimpse of 9 specific trends we are seeing from our vantage point of view, and which we as a company have to intercept in some shape or form. And what I see as 7 job-ready AI skills, which can be quickly absorbed to increase your probability of a placement outcome. So these are the
but you'll also be speaking from the perspective of data science, right?
Yeah, these are all data science perspectives. Yes. Yeah. So it includes the 3 areas: storing data, sensing information, and acting out of it. So we'll cover everything. Yeah. So one of the first areas we are seeing is what I call the automating the automators. The rise of low code and no code AI solutions. So if you look at many of the repetitive tasks which are there, they're getting increasingly automated. For example, tagging of images, generation of features in sensor signals. These are some of the repetitive tasks which happen, assessing the data quality of an input stream so that you can determine whether they're fit for purpose itself. Many of the times when you're trying to create an AI model, one of the first simple tasks to do is the quality of the data good or bad? You need to have a high, medium, low score on it. Those tasks are, earlier it used to be a lot of SQLs, homegrown SQLs, which would fire off before you figure out whether the data is fit for purpose. Today, with the click of a button, you can quickly assess whether the data is ready for model extraction itself. The second task is in feature generation. Explainable features need to be built in a data science or AI model. And feature generation used to be more of an art where every data scientist who came into the picture based on his prior experience used to generate a lot of features. But today there are a lot of tools which are available which will automate and standardize the creation of features itself. And one example of that is you can quickly go to Google. Google has this platform called Vertex AI, where some of these tasks are automated. And not just Google, I think all the players have started coming out with their own avatars of low code, no code solutions. So I remember long back when you used to have database systems, if you had to write an index to access a row, you used to create a B-tree index, a hand-coded B-tree index from scratch. But today that's completely automated. So similar thing you'll see in the AI side itself, where many of these repetitive tasks will get completely automated, or there'll be ready-made snippets of code which are available in a recipe form, which you can take and extend for yourselves. So the first strong trend we are seeing. The second strong trend we are seeing is, even from a job market, it is a little bit of specialization, domain specialization along with the AI skills or data science skills. For example, if you take retail, for example, if you have an appreciation for product cannibalization and as well as the analytics associated with it, that would be good. If you have an appreciation for multi-channel analytics as well as AI skills, that would be good. Similarly, in the case of healthcare, if you have an appreciation for object event detection, X-ray object event detection for radiological skills, that would be added missing. So domain plus AI or data science cocktail is becoming very, very important, what we call as verticalizing AI. Because I think horizontal AI, if you go out into the market, you'll find the supply is becoming bigger and bigger. But what you're finding out at dearth is in certain areas, putting the output of AI in the context of a domain. So verticalizing some of these skill sets would be really good. The third area is certain problem statements, for example, specifically in healthcare and fintech, getting synthetic data, getting real data is becoming difficult. For example, if you want to develop any AI model in Europe, it's going to be extremely difficult because of the strict GDPR compliance laws, privacy laws. So in order to do that, there are companies which are coming up which will generate almost real synthetic data. Okay, so from which you can extract good signatures, which are almost realistic to ground truth data itself. The simple example could be, while Google was trying to develop a diabetic retinopathy detector, they had challenge in getting eye data because of privacy issues in the US. But they landed in Madurai, went to Arvind Eye Hospital, they extracted all the database. They didn't have any qualms about sharing the pupil data, and from that they were able to extract the signature of a diabetic retinopathy outcome. So the point I'm trying to make is access to high value data sets is going to be crucial than the model itself. Model extraction will getting automated, but access to high value data sets like diabetic retinopathy, cancer data sets, all of this is going to be the battlefield where companies would win or lose. And one approach to doing that is generation of synthetic data. And you're going to see a lot of companies come up in the area of synthetic data generation. The fourth area which we are seeing a lot of this thing is in emotion detection itself. So we have algorithms which can today detect more than 98% accuracy in 9 emotional states: happiness, anger, joy, surprise, stuff like that. But for us, from an industrial setting, we have found it very useful to do a couple of things. So we focus on the oil and gas sector, and especially in the Middle East, when these the folks are operating in the middle of the sea, fatigue sets and when they work for 12 to 14 hours a day. And it's very important from a health and safety perspective to ensure that the person doesn't fall off sleep, or if he's not operating a critical valve when he's really tired, because it could set off a explosion event on the oil rig itself. So fatigue detector using these cameras, high resolution cameras, is a very, very important use case. And that can be done by extracting micro expressions from the face itself. In the auto space, you are finding a lot of use cases around road rage. So, or if you're drinking and driving, right? So there are checks and balances being put in where if you're drinking and driving, you're not allowed to do certain operations. If you're having a road rage, they max out the speed at which you travel and stuff like that, generally from a public safety perspective. And in security perspective, you're seeing at airports. So for example, if you go to Israeli airports, you'll find all their cameras that have emotion detectors on it. So in addition to the security analysis who's scanning the incoming set of passengers, you will have you will have this camera itself augmenting that. The camera detects a person who's nervous and is fretting a lot. He'll be flagged off for secondary inspection. So really detecting micro expressions, and there are so many complexities in doing this. Extracting the emotional signature of an Indian is very, very expressive, so you can easily extract the signature of human expressions. But when you're trying to extract the signature of let's say Asian, I mean, for example, the Japanese, many of them are not so expressive. It becomes a lot more challenging. So you're going to have a lot of nuances around geography specific emotion detection and culture specific signature detection, and there's a lot of opportunity to improvise and build stuff there. The other strong trend which is started just picking up is there is what do I call a lot of eye candy. So if you look at many of these data science or AI applications, there's a lot of dashboards, stuff lighting up and going off. So there is a lot of cognitive overload. So the human brain cannot process so much of information. So there are companies which are emerging, which says the human brain can process stories much more better than it can process a dashboard, because stories are in the form of English sentences and it activates a certain neural pathway. So dashboards are a cognitive overload, data stories are actionable. So this company called Narrative Science, essentially what it does is it crunches the data, extracts, let's say, anomalies, correlations, significant variables out of it, which impact an outcome, create an analytical output. And not only that, after creating that analytical output, they generate English sentences. So the analysts, if you look at a line graph or a pie chart or whatever, what they're trying to do is convert that graph into English sentence, which they can easily digest and then take an action. That bridge between looking at a graph and creating an English sentence, there is a lot of effort required. That effort is automated by narrative sciences. So converting data to stories is going to be a very, very important area to watch for. And if you look at large companies like Accenture, this is an area of focus for them in terms of recruitment itself. The other area is in the form of what we call, especially in the industrial side, I would say, is what we call cloudless edge intelligence. There is no cloud. So this is an LNG, this is a company called GTT out of France, for which we did a project, where there are a lot of cryogenic sensors, more than 200 plus cryogenic sensors, which were, it's almost like detecting certain threshold, it causes explosion mid-sea. So what we have done is essentially collected all the anomalies and predict failure before it happens. So there is no cloud of it. It's basically completely edge intelligence which you implemented there. And this is something which we are doing for the Indian Navy. Again, another example of cloudless edge intelligence for the nuclear submarines. We had picked up 14 different subsystems for which we are doing diagnostics as well as prognostics, predict when it will fail. So if a nuclear submarine goes out, let's say before the submarine out into the sea, they have to make sure that the pump doesn't go down, because if you're deep down, if it goes down, that it causes a lot of risk to the folks out there. So what these algorithms do is before the submarine
Hello. Hello, sir.
So I think we lost him.
Yeah.
Okay, he'll come back. Yeah, he's come back.
Can you hear me?
Yeah, yes. Yeah.
I'm just trying to, sorry about that.
No.
Let me just bring it up. You can see it right now, right?
Yeah, yes, that's it.
So this is another use case of cloudless edge intelligence, where before a nuclear submarine goes out into the sea, and as it's making its voyage, a continuous prediction of all these 14 subsystems would be done to make sure that everything is humming well. Sorry, this is a spelling mistake. It should be chips optimized for AI workload. So the other area where you're going to see is increasingly this specific workload of extracting signatures from specifically from sensor data streams and let's say X-rays and drone data is going to be a very computation intensive workload, and current chips may not be able to do it at the speed at which we expect. So there's a lot of money being pumped into coming up with proprietary chips, very sharply focused on these signature extraction workloads, AI workloads, I would say. And this is one area to keep an eye on, because as you increasingly start processing image data or sensor data, you will find that the conventional GPUs, so you can go and have dinner and come back before the whole signature comes out. So you want to increase the speed at which these workloads operate. And some of these companies like Horizon Robotics, ESWIN, are putting a lot of thought into creating AI workload specific chips in that. The other area, and this could be an area from an Indian perspective, could be a lot of toxicity on the internet, a lot of bullying and chat log information needs to be processed, and there are a lot of humans, especially for Facebook. You have an army of people in Hyderabad and Bangalore who are looking at toxic content or being put out there. So it's a very manual thing, and they're trying to automate it. And this is one area I think, especially in the non-English speaking areas, I think we can do a lot of work in detecting toxicity, I would say. And AI can help a lot, because you can't put an army of people and monitor everything. You'll need probably a hybrid model where the AI flags off certain parts of toxicity and the human can do the remaining. The next area, which is interesting, is what I would call multimodal AI. One second. Sorry. Yeah, it's called multimodal AI. Where, for example, traditionally you had signature extraction done on textual data or video data. Now what you're not able to do is associate certain long sentences with the video image. So for example, an armchair in the shape of an avocado can be quickly, the signatures can be quickly done. And there is a tool called Imagen, which Google has launched, which is an indication of things to come. Tomorrow, you can even integrate audio into it. You can integrate text, video and audio into it, so that what you have is multimodal AI out there. So from a job ready skills in 2022-23, what we see as having strong demand signals. The first area is what I would call specifically power grid oriented cybersecurity. So there's a lot of AI oriented forensics required. At least the Indian government is investing heavily on the northeastern corridor, where we have started experiencing power grid attacks from across the border, and securing that using AI is going to be a huge area. And especially after the Ukraine war, we are seeing an increased demand for this. The second area we are seeing is in the area of drone related AI. So there are two types of information a drone can emit. One is it can emit data regarding it's what we call IMU sensor data. Gyroscope data is collected. It can tell you how stable the drone is in flight, the sensor signals. And then it actually collects images of what it sees. So you can run neural networks to do object event detection on the image data. And you will need an army of drone operators. There are going to be defense applications of drones. There are going to be a lot of agricultural, healthcare related applications of drones going forward. And all of this require almost like your pilots, you'll have to train drone operators, and every person will have to get scored in a simulator. So AI does a lot of things in terms of making them fly these drones and find out, are they landing correctly? Is it a rough landing? What is the angle? What is the speed at which they do? Do they do jerky accelerations? So every in-flight behavior would get observed by the AI algorithms, and a cumulative score could be given. It's almost like your driving test. So every acceleration, every brake is observed by a person. So instead of a person, AI would do it and score it. And similarly, if you're using AI for agricultural purpose, already there are a lot of companies doing detection of certain crops and stuff like that. So a lot of use cases around drone AI itself. Defense is going to be an interesting area where you're going to see a lot of applications. This is an example of the soldier of the future from Boston Dynamics. This is actually a working prototype where two autonomous robots can synchronize with each other. So yeah, you can take a look at it. It's very interesting. There's a second robot coming. So if you look at it, so there's going to be a lot of edge intelligence on it. So a lot of high processing, a lot of events had to be detected in real time, and a lot of closed loop. You have to respond and send a signal to the controllers managing the robot itself. So a lot of high frequency time series analysis on the edge, anomaly detection, event detection, object detection. So what I call machine vision intelligence is required on the edge without any cloud. And that's a huge area where a lot of potential exists, even in India. So if you broadly look at it, if you have to understand, I come the industrial AI space. So if you have to understand what the upside potential is in terms of jobs. If you look at the journey of a car, earlier it was 0% digital. You didn't have any sensors on it. Then you had some basic edge intelligence. You know, your car door is open. You're not wearing your seat belt. Simple heuristics which would flag off an alert in the car. And then today you have sophisticated edge intelligence. You can help. It will help you parallel park itself. So there is some additional vision intelligence. Then today Tesla has over-the-air updates, so they can completely upgrade the car without you going to a technician, because it will send you a patch of software and additional features are activated on the car itself. And there's a lot of new business model which comes monitoring. As today they charge, Ford charges $25 per month to monitor the health of your car itself. It's an additional source of revenue, and everything can be done by what we call as the AI doctor, which diagnoses and prognosis the health of the engines and the braking systems and everything, transmission systems. And the last step is what I would call autonomous system, which is completely no human in the loop. But if you look at it, this has been the journey of the automobile in the last 50 years. But if you look at a motor, a pump, a tank in the Indian Army, all of them are at the first two levels, basic zero intelligence or basic edge. Over the next 4 to 5 years, all of them will have to move to 3, 4, 5. And every step is an opportunity for employment and startup value unlock. So, and that's the whole potential we are talking about. The other area, especially from an Indian context, where you see a lot of opportunities is in the area of electric vehicles, specifically a lot of AI related to battery analytics and motor analytics. So if you have electromechanical engineers who can understand and predict the life of a battery, electrical battery, or efficiency of an electric motor, for example, that would be huge. So a lot of skills required in these two areas in the electrical industry, electrical motor and automobile industry. And also in the energy industry where we operate, we are seeing that there is a lot of investments going into, billions of dollars are going into alternatives to carbon fuel. So it's very corrosive to the atmosphere, all of you know. So simple examples of that we have already started doing is emission-related analytics from refinery. So any emissions which happen, there's a lot of sensors which collect the amount of nitrogen, carbon which goes out there. And there's a lot of analytics you can do to squeeze insights regarding patterns of emission from various plants and score the plant itself. So we're doing this for refineries and chemicals in Houston. The other area is if you're not emitting, for example, steel plant, we are doing work with JSW steel plant. So they want to make sure that they're not guzzling so much energy. So there is a lot of boilers which operate, and are they operating at the right level of efficiency? No, which is going to fail, which boilers are going to fail from an efficiency point of view. All of this can result in the movement of the needle from an emission perspective. And net zero is going to be a very huge area. So any work which can be at the intersect of AI and net zero would be huge. And I also believe most of the future jobs are not going to be unidimensional. It's going to be multidisciplinary, multidimensional. Just to give you an example, in our space, where we are monitoring the health of equipments and processes globally, sitting out here in Bangalore. You'll need to understand digital twins. You'll need to understand IoT, sensor fabric. You need to understand AI, and you'll need to understand AR, VR. And unless until you get this cocktail right, or this ingredients right, you're not going to deliver impact to the customer itself. So it's going to get more and more multidisciplinary and problem backward, I would say. The other area, this is possibly not so a glamorous area, but there's a lot of money in it and a lot of jobs which are going to get generated, I would say, is in the creation. So traditionally, if you go to a bank or a retail company, they have a banking data warehouse, they have a retail data warehouse, even internet companies, they have a clickstream data warehouse, which is a repository. But 80% of the data, which is going to be in the next 2 to 5 years, I would say would going to be unstructured, and bulk of the effort required is not going to be in extracting and pattern out of it, is going to be in wrangling the data. It's going to be very labor intensive, drone data, satellite data, LIDAR data, thermal data, radiographic data. We're also talking about radar data for this thing for the Indian defense. All of this data, there is no data lake at all today. So just building operational data lakes is a massive business, and they will need thousands and thousands of people who are focused on building non-structured data lakes. Structured data lakes exist, but engineering unstructured data lakes, sound related information, all of this, the infrastructure just doesn't exist. So just laying out the digital, what I call rail, the plumbing layer for that, before you can start doing a lot of AI apps, this foundation has to be set in. And there's going to be a lot of opportunities in creating job ready skills in what I call ground truth database building. From where we are, this is from the point of view of a startup, we expect all our people to be human-centric, as I would call it, but means you need to understand who's going to use your application at the end of the day. Is it going to be a reliability engineer? Is it going to be a safety guy? Is it going to be a maintenance guy? In the consumer side, is it going to be the head of guy who's allocating budgets for marketing mixes? Is it could be a brand guy? Is it be a channel guy? You need to understand clearly the persona who's going to consume the output of the AI. So that's the human side of things. The second important aspect is, what is the economic impact of your solution? It's also very important, because I think many a times we get excited by the shiny new algorithms we have, but business will fail to support you because they don't understand what is the impact of that AI output on their balance sheet. So the ability to link your AI output to a balance sheet outcome is extremely important. And that's going to determine you'll get funded for projects or not itself. The third is domain centricity. We spoke a little bit about, a lot about it. Understand you're able to put the AI in context. You can't recommend what actions need to be taken based on the insights from the data. And especially going forward, I think a lot of stuff will be problem backward and not algorithm or math forward. And last but not the least, we talked about database storytelling. And from a business perspective, what we are seeing is 3 very important trends which we think will massively disrupt in the next 2 to 3 years. There's a lot of homegrown AI. So every time you want to predict the failure of a motor, there is somebody writing a code from scratch, but that will grow. And slowly we are seeing the rise, at least in certain sectors, the rise of prepackaged models for motor failure prediction, vibration failure analysis. The prepackaged apps are coming out, domain-based models, and that will increasingly grow. The second trend we are seeing is movement from handwritten AI. Everybody will open up Python thing and start writing from scratch to low code, no code solutions. I think automating, we are doing this already within the company, where instead of writing everything from scratch, the data scientists can focus on more high value adding activities. So these things will not shackle them, data massaging, feature generation, all of those mundane activities can be automated with 1 to 5 clicks. And he can focus more on model selection. Sometimes that is also automated. AutoML tools are able to automate, which is the right model. But again, putting it in the context of a domain is where the value is going to be. The third area is many of the companies who are going to be your potential employers, you have to understand where they're going to go. Earlier, they used to get paid to deliver an output. I'll give you a particular model and get paid for that output. Increasingly, companies are going and said, I don't want to pay you for the model. I want to pay you for outcome itself. And that has serious repercussions, which means you need to understand the attribute. For example, if you're predicting the failure of a mission, what repercussion that has on the production of oil and the amount of revenue they make has to be clearly linked. So movement from an output-driven business model to an outcome-driven model will require you to know more about the business itself. Otherwise, if there are two people who are standing in line for an interview, one person is able to link the output to an outcome, the other person cannot. The person who can link the output to an outcome will win the game. So those were the few thoughts. I'd be happy to take any questions you have.
Derek, you had put a bullet, data storytelling or something. I'm not sure you spoke about it.
Sure. So for example, so if you look at this company called Narrative Science. So for example, what they do is, if you go to Wall Street, right, they Standard & Poor's, right? Standard & Poor's, they have a lot of internal data and syndicated data, risk scores they have, GDP data from multiple. So there's a lot of data which is processed, a lot of graphs which are created. What they do is take all those graphs and say, here are the top 5 important insights from this graph. For example, they say, I see a correlation between risk volatility and the GDP index of the country. That sentence is actually created. Okay, so though people do not look at some 15-20 graphs, all they have to look at is 5-6 bullets, sentences, and the sentences are auto-generated by this Narrative Science software. So think of it normally in a typical analytics projects, we deliver, let's say, some 30-40 graphs, correlation outputs in a deck. That whole thing is boiled down to top 10 insights which are actionable in the form of simple sentences. And that is going to be a very important activity.
Is storytelling, data storytelling is a job role today?
It is a skill, I would say. It's not this thing. It is an additional skill they look for in a data scientist. So if there are two people, one can convert the data to stories, the other stumbles. The guy who can convert the data to story wins.
Okay. Okay, Srija.
Yeah, sir. Yeah. Thank you, Mr. Derek. Okay, it gave like what are the research going on in the industry, what are the recent research going on, and what are all the 9 trends in evolutionary AI, exponential AIs, and what are all the skills required for immediate job roles, right? And what are all the job opportunities available? So you have discussed a lot, and we have some questions from our students. So first question is, I'm planning to take up data science for my MS major. And is it the right choice or should I go ahead with computer science? This is for higher studies. Okay, but yeah, we got this question.
No, so at the end of the day, I think all of you have to respond to what your heart says. You should not listen to an outside voice. That's my personal view, whatever your heart says. But from a job perspective, I'll tell this from a job demand perspective. I think computer science gives you a lot of foundational skills in platform engineering and a mix of computer science and data science. Today, if you go to see, it need not be either or, you can take electives. I'd say data science prepares you for understanding how to extract patterns out of the data, but it has to be done at scale. And many of the vanilla data scientists, for example, in our company, we had data scientists who could do this on let's say, 100,000 sensor events. The moment you say I have to scale this to 1 billion sensor events, it took us a completely different thought process and scale. So you need platform engineering skills. I think computer science teaches you platform engineering skills, which is a very good thing. And data science will teach you the breadth of techniques required to extract. I would say it's not an either or question. If it's possible, see if you can mix the two.
Okay.
Yeah.
Thank you. And another one is, are there enough job opportunities in India to get a job in the field of data science and machine learning? If yes, could you tell us how to crack a data science role?
Yeah. I personally believe, I know for a fact on the industrial AI side, Bangalore, Chennai, Pune are becoming the hubs for industrial AI globally, where you have I don't know if many of you know, Bangalore had the highest number of credit risk modelers in the world in the late 90s and early 2000s. Okay, so it was not called AI or anything, but credit risk analytics. It's a similar trend is happening in specific verticals. I could see that. Industrial, definitely it is happening. EduTech, it's happening. FinTech, a lot of work is happening. So India is definitely becoming a global hub for AI. And it's definitely very lucrative. The salaries are also almost Western grade in very specific areas, I would say. In terms of what is a path towards doing that, I would say people would look for proof of execution. So the more you can create live projects and put it on GitHub, the best way to do an interview would be not to get into a format where the interview asks a question and you respond to it. Open up your most complex GitHub AI code and do a code walkthrough. Okay. And the more you can do that, if you can show the breadth, you have to show and tell. Okay. The more you can show and tell in an interview, the much better it is. So keep collecting projects from rich projects, I would say, some in text mining, some in sense analytics, wherever you feel critical mass is, but keep collecting projects. Make sure that your evidence of execution on GitHub, and make sure that you can communicate what you've done in a very coherent manner as a part of the interview.
Okay. Thank you, Derek. And one more question, follow-up question for the first one. You said actually, whenever a person is joining in an industry as a data scientist, they will be working on building ML models and scaling them. Apart from that, what a data scientist will be doing in the industry as a fresher?
As a fresher, right? So I'll be honest about this. When you join as a fresher, so if you look at it, the value chain of the data science process, there is upstream process and there's downstream work. Upstream is, you collect the data, you mash up the data, you wrangle the data, create the features, build, and do some initial exploratory data analysis on that, maybe do some correlation automation. So that's what most of the people in industry do. The downstream part is the more glamorous part, where you will extract the pattern out of it, you'll identify which model to fit in. Then you'll convert that into a coherent narrative storyboard, as I said, convert that in plain English sentences, and recommend actions to be taken. So in the sense, for example, Accenture, if you go to say, they will do a retail analytics project, and based on analyzing their channel data, they'll say, here are 5 actions you should take on the user journey to improve your conversion rates. So action recommenders, so these are all downstream actions. So I would say in the initial part of the journey, most of the time, folks would spend in the upstream part. But I don't think it's necessarily a bad thing, because you need to get your hands dirty to understand what are the friction points required in integrating data, massaging data. I know most people do not like it, but I think it's very important to get your hands dirty to understand the pain required in the upstream value chain. And once you have a solid experience of that, shift to the downstream side where you're extracting the insights, recommending an action, and closing the loop on the economic impact itself.
Okay. Thank you, Mr. Reddick. Okay, thank you for the answers, all the answers. Okay. Sir, you want to say something, Director, sir?
I think it's one.
Sir?
Okay. Yeah. Thank you, Derek, for joining. And we look forward to continue our relationship in all possible means.
Sure. Thank you all. Have a wonderful evening. Bye-bye.
Yeah, thank you, sir.
Thank you.
Yeah, good evening, Supriya.
Good evening, Dr. Srisha.
Yeah, good evening.
Yeah. Hello, Supriya. Good evening. I'm Dr. Kannabiran.
Good morning, sir. Good evening, sir.
Good evening. So Thank you so much for joining. And Srija, can you please take over the session?
Yeah, sir, sure. I'll take over the session. Yes, good evening, Supriya. I'll just give a brief introduction about you. Yeah. So we have our last expert, Supriya Raman. Ms. Supriya Raman is a Vice President in Corporate and Investment Banking and Lead Data Scientist at JP Morgan Chase & Co. According to Analytics Insight survey, Ms. Raman was among the top 10 Indian women data scientists in 2021. She is also serving as a career mentor for Upgrade. Prior to joining JP Morgan Chase & Co., Ms. Raman served as a data scientist in Levi Strauss & Co. and data analytics lead in ANZ Banking Group. She played various leading roles such as technology lead in iGate Global Solutions, module lead in DXC Technology. She is having more than 16 years of experience as data scientist, proficient in designing and developing statistical and predictive machine learning models for identifying patterns and extracting data insights. Over to you, ma'am.
Thank you so much. And very good evening, students. I understand it has been a 2-day session for you, and it had been very informative. Thank you for giving me this opportunity, and I'll try to keep it as informative as possible. I'll share my screen. Today, my topic to share with you is about data analytics. And I understand the topic which you have selected is data science trend and career. So when you talk about is my screen visible?
Yeah, ma'am. You can go for a full screen mode.
Okay, sure. Just a moment.
Yeah, go to slideshow and
Yeah.
give yes.
Is it okay now?
Yeah, yes, fine.
Okay, perfect. So I was talking about the career building in data science, and I understand all of you students are more, peculiar about how we can make our career in data science and machine learning. It's a very hot, trending industry these days, and almost all domain. We have several domains, and across all domains, we have different kind of job profiles which we have, right? So a person who has, for example, I'll take my own example. I have worked 16 years in banking, right? And working 16 years in the banking, if you suddenly want to work for retail, it actually sounds very different because the domain is not known to you, right? So data science and machine learning is such a vast field, and irrespective of any domain or any industry which you have this field. I'm typically talking from the career perspective, right? So no matter whether you are a banker, so I was talking about myself. I have 16 years of experience in banking. Mainly, I have worked for bank. I have worked a long time for ANZ and JP Morgan. Washington Mutual was one of the banks which was earlier picked up by JP Morgan. I worked for a long time for Washington Mutual. So after working for a long time in banking, I thought of picking up retail, and I worked for Levi's for some time. And the career transition actually become very smooth when you are in data science. So when you talk about data science, there are 3 important pillars which governs it, and they are data, the domain, and then the technology. So technology, you don't have any control on technology, because technology will keep on advancing and it will keep on updating, and every time you will have, if you talk about C, C++, all of these are now kind of very native language, right? We are now in Python, even SAS and R, they are not very relevant in the market. So most of the codings are being done in Python and other languages which are more relevant. So technology keep evolving, but what keeps a very important pillar for us is the domain and the data. So if you have to understand data, you have to understand the domain very wisely. And that's why people switching across domain, it becomes very difficult. But having said that, in data science and machine learning, we have this privilege because, specifically talking about the natural language processing, you have this privilege till when you understand the data, you can easily switch your domain and easily switch your industries. Having said that, I'll start with my presentation today. Today, I will be talking about NLP, which is natural language processing. It is widely called text analytics. And, basically, when you talk about NLP, it refers to the data science or AI branch, which is concerned of giving the computer to understand the language as we human can do. Right? So as a human, when we talk or when we write, we actually don't write in a very formatted way, right? We don't use a formatted English. We use a very human-like language, and we have to make our machine also understand, because there are a lot of social media data which has been generated either in Twitter or Facebook or any other platform, where all these are human generated languages, and we want our models to understand that. To make that, to make it efficient, the tool which we use in data science and machine learning is natural language processing. That branch of it is called natural language processing. Also, we have to understand that when we talk about social media, there are different type of data which we have, right? You capture the data either in video or audio or image or text and many other forms. But text is something which is captures 80% of your content, right? And this data is huge. It's a huge data, and also it's very, it's growing exponentially. Not only that, we have a data today which is very huge. That's why we have big data and other cloud platform which goes hand in hand with these technologies, right? So before we switch into what is NLP or what is text analytics, I like to talk about how the communication of our as a human, how our communication has changed with the machine. So the first picture which you see here is about the punch card. Long time ago, it's in 50s and 70s, we had punching machines and also the punch card readers, right? And these punch card were actually very bulky machines, where the information which you can print onto it was very limited. And then you had, it was a very time consuming process to punch it first and read it, right? The middle picture here is about mainframe or AS400. It might again sound as a very legacy system where, the mainframe will sound native and it might sound, but most of the banks, most of the major bank, the core banking of most of the major banks still works on mainframe. So this screen is picked up from mainframe. And later the third picture which I have picked is of the chatbots, because most of the domain again, especially with the COVID, right? When the COVID happened, because I had been a part of Levi's, I'll quote that. So when you go to a Levi's shop, right, when you're trying to select any product, you have a specialized salesperson who is helping you, right? So you have your own recommendation, but at the same time, they would recommend that, why don't you try this? This will go good with you and so on. And you rely a lot on those salesperson, right? But when you do online shopping, you don't get that, right? You don't get that privilege of having that so many recommendations. So that's why the chatbot became very relevant, especially in COVID. Almost all platforms put their chatbots, so that the first interaction, first few interactions which you want with your customers can be easily done with the machine, right? Before the human can reach there. Another example of chatbot which I can give is in ANZ Bank, again with the COVID only. In banking, when a complaint comes to us, right? The complaints can be a normal complaint from a customer. At the same time, it can also be a breach. And if it is a breach in a banking, you have to handle that breach in a very short stipulated point of time. But with COVID, we were getting so many complaints, the operators were not able to find out whether it's a breach or a non-breach. So we put a simple classification model there, which can easily classify the complaints into breach and non-breach. And that model was kept using this chatbots. So we put a chatbot onto our operator machines where, the chatbot can quickly interact with the customer, and then with the initial interactions which we have, they can figure out whether it's a breach or non-breach. And the last picture here is about the talking machines. Almost all houses we have, that you will have Alexa or Siri, one of these surely you will have. These are again dealing with text, but in a speech form. And that's why we have an additional step there where you convert first the speech to text or text to speech, and then you interpret languages. We will talk about some of the areas of application where NLP is very relevant, but these are not limited to these. These are just few very, very famous area of application which I have picked up, but actually the area of application is very vast. So the first one which I picked up is about social media analytics, and almost all industry, they want to know how their customer are talking about, what they are talking about their products. I would like to quote Rohit Shetty, if you are a fan of Bollywood, right? And he's a famous action hero. I'm sure he will be many of you might be knowing him. So if you see his interviews whenever he releases his films, he says that he want to go to the movie hall and then he want to collect the first hand expression of the customer, how they are expressing their emotions onto the scenes, right? So, but not all of us can be as advanced as he is, right? We cannot read the emotions so closely. And thanks to social media, because social media actually collect a lot of feedbacks from the customer. We have a lot of text which we can analyze, and then we can, find out the analytics out of it. Again, in banking and insurance, for sure, NLP is very vast. I gave you some example. Another example which I can give you is about the loan application or the insurance. Whenever you apply for any loan or any insurance, there are a lot of, in the form which has been given to you, there are a lot of fields which captures most of your data, but at the end, they always provide you a text field, okay? Those fields are actually free form text, where you can enter your free text and they capture this text because they want to find out the sentiments behind a customer applying with this application, right? The third one here is about the automatic summarization. We have huge number of documents, and we know that the documents are tremendous, right? No one has time to go through such large documents. So there are tools which actually take a huge document and they summarize it. There are different ways by which you can summarize. There are extractive methods, and there are different algos which you use for summarizing. Basically, when they summarize, they put it into key points about what they have extracted from the document and they present it to you. Speech to text, we already talked about with the machines which we have, right? With Alexa. Other thing you can talk about is Google search. When you have to do Google search, many a times, we don't type nowadays. We just say, Google, can you find, and then it quickly find it out for us, right? So speech to text, again, Amazon Prime remote, right? You generally don't type what you want to search on Amazon Prime. You generally speak onto it and it finds out for you. So those are some applications where speech to text is relevant. This is another one where we have image captioning. So when you talk about image captioning, if you can see what it is happening here, it is taking a picture, right? And you have to caption it with some text, right? So first, what it is trying to do, it is trying to label all the objects which find in the picture with relevant words. And then it is trying to keep these words in frame sentences out of it, these words. And then it also re-ranks these sentences in order to figure out which is the most relevant sentence to caption the pictures, right? So image captioning is another application. Chatbots we talked about. Chatbot is one of the very common application of NLP. You have a lot of tools, not only the native way of developing NLP, you have a lot of tools which help you develop, like NLU is one of them, and then Amazon, you might have heard about Cloud, AWS. There are a lot of tools which has been specifically designed in order to help you design the chatbots. And lastly, I want to talk about the sentiment analysis. Now, sentiment analysis is very similar to what we talked about social media analytics. But in sentiment analysis, you basically talk about polarity. Okay, you generally talk about whether if I give you some text, whether you want to understand it's a positive feedback or it's a negative feedback. I'll again like to quote one of the case study which we did. So when I was working in Levi's launched a fabric just before COVID, and then the COVID started. Every time when they launch a new fabric into the market, they want to understand whether this fabric has gone well with the customer or not. Okay, and they collect a lot of feedback from the customer on the social medias. But because of COVID started, they didn't do any analysis onto it. But once we recovered in 2021 last year, they started developing the sentiments around this fabric. Okay, so there are a lot of texts which has been published for these fabrics, and we did a sentiment analysis in order to understand whether it has gone well and it has not gone well. This is all it wants, but I'm talking about only the bipolar case in this case. But you can have polarity. It can be as granular as putting different layers of granularity, right? Whether you want to know it's very positive or neutral or negative or very negative and so on, right? So that's what sentiment analysis is. There are a few more applications which we have. I'll share this content with Dr. Shisha. About talking about text, when we talk about text, right, there are three main steps by which you can understand that text. So when you do text analysis, there are three major steps. One, the first step here is about the lexical processing. When you say lexical processing, you try to understand the raw text. Okay, so you have the raw text, you take the raw text and then you tokenize it. When you say tokenize it, you try to break it into pieces. Breaking into pieces can be as granular as word format, or it can even be sentence format, or you want to understand the whole paragraph. It can be any level. So tokenizing means taking a raw text, breaking into pieces, and then trying to understand the meaning out of it. Okay. The best example of lexical processing can be understanding whether a mail is spam or ham. So most of us will have a Gmail account, right? And in the Gmail, there is already a folder which is marked as spam, right? So Gmail is smart enough in order to recognize some of the mails which it automatically identifies and put it into spam. Those are some of the lexical processing applications where they just work on the word. They are not worried about the meaning of the sentences. They are not worried about the grammar of the sentences. Just picking up the words they can find out. So if your mail has a lot of special characters, or they have flashy words like sale or hurry, and then you can understand how the spam looks like. So they can catch those and they can classify it as spam. So that is lexical processing. Once you understand the raw text and the content of it in the tokens, then the next step which we do is about the syntactic processing. So when you talk about syntactic processing, you are actually talking about the language of the sentence. Okay. So what does that mean? So understanding the language of the sentence is, suppose I give you two sentences. The sentences are Ram thanked Shyam and Shyam thanked Ram, right? So in lexical processing, I told you that you can break it into words and then just understand the meaning, right? But in both these sentences, actually the words are same, right? The Ram thanked Shyam or Shyam thanked Ram, it's the same words, but the meaning is totally different. Why? Because we have different subjects, different objects, and different predicates, right? So that's what we do in like the syntactic processing. In syntactic processing, you actually mark the part of speech. So you identify in a sentence what is noun, what is verb, what is adjective, all those things. Also, you identify which part of the sentence is, whether it is a subject, whether it is a predicate, whether it is an object, and so on. Okay. So this is about syntactic processing, right? You try to understand the language of the sentence itself rather than just understanding each word or each token separately, right? And then the last one here is about the semantic processing. When you try to do the semantic processing, you actually try to understand the meaning of the sentence, right? So suppose I say I saw a cat. As soon as I tell you I saw a cat, as a human, you can understand what a cat is, right? You can immediately think of an animal which is small and it has two eyes, one tail, and so on, right? But when I tell this to my model, can my model also understand that what is a cat? So how will I make my model understand? So I have to supplement it with extra informations, okay, other than the information. So one is a text which I will give you to process. Other than this text, you should have additional documents or additional supporting documents which can provide it more information. And that is what semantic processing is. And that's why the cloud here shows that you need general knowledge, you need domain knowledge, and discourse content. When you say general knowledge, again, giving you example of general knowledge is, suppose you are reading a document, okay, and it says Prime Minister Narendra Modi, or it says PM Narendra Modi. As a human, we understand that the PM and the Prime Minister are same. But can my model also understand that? And that's general knowledge. We have to supplement it using extra, might be glossary kind of thing to our document. Also, the domain knowledge, as I said, each domain behaves very differently. Specifically, the domains like medicine or those kind of domains where you have a very specific taxonomy attached to the domain. So you have to supplement extra information along with your own document in order to process those. And discourse context is where the same word can have different meaning in different point of time. For example, take the word bank. When you say bank, it can be financial institution. It can also be the river bank, right? And depending on how it has been used in the sentences, it will have different meaning. So that's what discourse context is, right? So these are the 3 steps which I try to explain you. That is lexical processing, syntactic processing, and semantic processing. And when you do all these, you have the applications which we already discussed, right? So we discussed about some of these applications already. On the right side of the page, you can see shallow and deep. Now, when you talk about NLP, this is a very common thing which we have when you say shallow processing and the deeper processing. So when you say shallow processing, you actually start with the text, and then you talk about speech and the phonics and so on, but as and when you go deeper and deeper, right? So you start with lexical processing and you go deeper, and then you talk about semantic processing. So as and when you go deeper, you reach discourse, pragmatic, semantic, syntax, and so on. Okay, so this is about shallow and deep. This is one example of semantic processing where the sentence actually means something else, but in order to understand the sentence, you have to supply extra informations, right? You have to supplement your model with extra informations. Now, deep learning, although we are talking about NLP, most of you might already be aware that nowadays we don't have this native way of dealing with the machine, native way of dealing with this natural language processing, right? How we discussed. We have basic libraries of Python like NLTK and all, which has been developed initially. They still exist, but most of the processing nowadays are going hand in hand with deep learning. So you have NLTK, you have the core way of dealing with the text. At the same time, you have deep learning architecture. And these deep learning architectures can be as simple as using ANN, CNN, RNN architecture, but the most relevant one, which you can hear now, Google has BERT, Distilbert, there are a lot of them, right? Robota A, there are a lot of deep learning architecture which has come. They are all transformer based, transformer or encoder decoder architecture. So this is again a different topic altogether. So I will not go in deep, but in this slide, I just wanted to say that when you are doing text analysis, most of the text analytics which we do nowadays go hand in hand with the deep learning. And also when you are using deep learning, it requires a lot of processing. Okay, so mainly if you're putting a deep learning model, you cannot process those models on your normal CPU. You either need GPU or TPU. There are a lot of processing and even the storage information which has been required. You require a lot of data in order to train your model. So you have to be wise enough when you're putting a model, whether you want a native way of developing it or deep learning is required. If deep learning is required, if you need more accuracy, you have support of processing, you have your machines upgraded for GPU, TPU, then you can go for deep learning. Otherwise, some of those tasks can be as simple as putting the native models using the normal libraries. Okay. Deep learning. Okay, now when we're talking about deep learning, there are 2 things in deep learning. One is a neural network. Now, when you talk about neural network, you can see this is an example here where you have a picture of a bird, and using this bird, it is doing some, we are not going into deep learning detail, but I'm just trying to explain that when you do neural network, you actually don't do attribute selection. Feature selection is not done in neural network. What do you mean by feature selection is, suppose I want to process a loan, right? And I want to find out whether this candidate which has applied for a loan will actually take a loan or not, right? In that case, which feature will be important for me to process in the model, that has to be decided by me as a modeler or as a programmer, right? But when you do neural networks, you get free from it because you cannot actually define all the features for an image or a picture like this because it's very complex. Whether you will define the colors or whether you define the pixels, what you will define, what you will not define is very complex. In neural network, the feature selection happens itself and then it finally decides the model. Okay, this is neural network. And in the reinforcement learning which we have, So basically, when you talk deep learning, it's combination of neural network and reinforcement learning. Also, when you talk about reinforcement learning, I can give you example of a robocar, right? So especially in reinforcement learning, what happens that you have an environment, right? And you have an agent. So taking an example of a robocar, our agent will be this robocar. And every time that agent take an action, so what will the action robocar will do? It will drive, right? So if it drives and it goes through interaction with the environment is anything around the car, right? So it interact with the environment. Every time it interact with the environment, it will reach a new state. That new state for a robocar can be a next designation, or it can even be an accident. The state can be anything, a new state can be anything. Similarly, the reward for each state it reach, it gets a reward. So the reward can be reaching your next destination, reaching the target, which milestone which you have set, or even meeting an accident. It can be, again, reward can be positive or negative. So every time an agent interact with the environment, it reaches a new state, get a reward, which can be positive or negative. And depending on the reward it has received, it again decides this action. So in the reinforcement learning, you generally don't have data to feed to your model where you can train your model based on those data. You actually have to, cultivate those data. You have to take those actions, rely on what reward you get, and then decide. And that's why it keeps on improving, as and when you train the model more and more, it keep on evolving. So deep learning models are mainly the combination of both. And as I said in the previous slide, most of our natural language processing models which we have nowadays are in hand with deep learning, right? Text encoding. We understand that machine only understands 0 and 1s, right? So when we talks about NLP is all about text, right? So you're dealing with text, and we have to understand that the text cannot be directly fed to the model. So if you're feeding the text, you have to generate some kind of metrics for each of the word, or each of the letters, or each of the character which you are feeding. And that's why as and when you will go through the model, you will understand terms like bag of word and vector representation of each word which are being fed into the model. For now, we have to understand that each text which you feed are actually encoded, and the most basic way of encoding which we had long time back is ASCII, right? ASCII is where we started. It had been in 1970s when we had ASCII. Only limitation with ASCII was it can only represent in 256 bits of information, and that's why it can represent most of the English characters and few special characters. And that's why soon later we have Unicode coming up. With the Unicode, we had two versions, UTF-8 and UTF-16. Now, these are all for the understanding. Most of the libraries which have been provided to us are already trained and encoded using these ASCII or Unicode. But we should understand as an NLP developer or as a data scientist that the text is not what the machine can process. It's just a number, 0 and 1, and that's why the encoding is important. These are some of the representations which we have across different codes. Now, another term which is very common in text analytics is corpus or corpora. When you say corpus, it is just a collection, huge collection of text which are annotated. Now, what does that mean is, now you take any library, the most basic library in Python for NLP is NLTK. Most of these libraries are actually trained on huge amount of data. They want huge amount of data to be trained, and that's how you just use their system defined functions to accomplish your task. You need not write it from the scratch. For example, suppose you have to identify all the garbage words in your text, right? You need not write that algo again, because that algo has already been trained and put in the model. The model has been trained on a huge amount of data. So those data on which those models have been trained are actually the corpus. As I said, NLTK is the most basic library which we have in Python, and it has been trained on this one. Sorry, it has been trained on Wall Street Journal, which is WSJ, and the corpus is known as Penn Tree Bank. Also, we have other corpus also, which are more relevant, and there are different libraries which are using different type of corpus. These corpus can also be defined by us. As I told you, especially for the domains, like if you're dealing with medicine or any other typical domain where you have a very different type of words, then you can supply your own corpus also to train your model. Regular expression. Now we talked about lexical processing, where he said that we just want to understand the word irrespective of what language or what extra semantics the text contains. We just want to understand the language. There are different ways of doing it, and the most basic way of doing is regex or regular expression. When you say regex or regular expression, it actually means that you want to identify some patterns, okay? And as long as you can identify some pattern in the text, you can define it using regular expressions. So I have some examples, like suppose you want to identify, you have a huge document, right? And you just want to extract all the Twitter tags from that. So we all know that a Twitter tag always start with a hash, and after hash, you will have some text. This pattern we can define it. We want a text which always start with a hash character, and then you have text following it. Similarly, if you take a phone number or Aadhaar number, anything, if you say phone number, they are 10 digits, right? So we can define a pattern that it should have 10 length only, and each of these 10 digits should only be numbers 0 to 9, right? So as long as you can define your pattern, you can use lexical processing very easily using regular expressions, right? Now, this is a very interesting slide where we have zip law. What this slide shows is, now suppose you have a very adequate size of document, which is not very small or very large. It is good size of the document. Now, what we do, that we take each word, okay? We take each word of it, and that's what is called token. So it has taken each word of it, and then it has calculated the frequency. Frequency means how many times this token is appearing in your text. So that's what is mentioned here, and we have captured it like this. Now, this graph actually shows that if you plot this, if you plot the frequency of the word, which is here, right? Frequency of the word, cross rank of the word. Rank of the word is actually, the rank is 1 for the, because this is having the highest frequency and so on. Okay. So rank 1, 2, 3, 4. The rank will be 1 for the word which is the highest frequency. And if you plot a graph across the frequency of the word and the rank of the word, you will get a graph like the blue line here, right? And what this graph shows, that there are huge number of words which are actually touching your y-axis, and it shows that there are huge number of words which are very high frequency words. You can see it in this example also, that which has been captured. But the high frequency words are actually the words which are just a connector in the sentences, and we don't need it. For example, the, of, to, and so on. These are words which are just the connectors. They don't actually explain the text, right? And that's why these are called stop words. These are high frequency words, but we want to get rid of them because they don't contribute to the meaning. And that's why they are called stop words. Also, you also have the rarely occurring words. So the one marked in yellow here actually shows, so again, giving you an example. Suppose you are reading a biography on Sachin Tendulkar and you come across the word Kenya. Might be he has visited Kenya, right? So 2 or 3 occurrence of the word Kenya comes, but because I am trying to capture information about Sachin Tendulkar, the word Kenya might not be important for me, right? So those are rarely occurring words. So we understand that in each document, you have high frequency words, which actually have very high frequency, but they are stop words. They don't contribute to the meaning of the sentences. And similarly, we have rarely occurring words. If you define your upper cutoff and the lower cutoff of these frequencies, then in between are the words which are actually significant words, which are marked with the black, black lines here. And these are the significant words which we want to process. Okay. And this is called Zipf law because it has been proposed by one of the scientists named as Zipf. This we have done. Okay. Now tokenization again we have done, because when we say tokenization, we understand that we take the raw text and we break it into pieces. This is exactly how we do. So if you are breaking it into word, I've taken an example from NLTK library, which is again the Python basic library. We have 4 types of tokenizer here. You have word tokenizer, which breaks into word. You have also sentence tokenizer. You have Twitter tokenizer. Twitter tokenizer are very smart because in Twitter you have emojis, you have hashtags, and they can recognize, because if you try to break emoji using a word tokenizer, it cannot actually classify your emojis. And sometimes you have to capture the emotions just based on emojis. Okay, there are applications where we just try to capture the emojis which has been kept as a feedback, and we want to classify it. So Twitter tokenizer help in that. Also, we have regex tokenizer. Regex tokenizer, we understand that we can identify some expression, regular expression, and then we can tokenize our text, right? Bag of word is another thing. Now there are very special way. We have Specky, and there are a lot of other methods which are more relevant of creating a bag of word. But I just wanted to make you understand how this vector representation of the word is being done. So this is the most basic example. Suppose you have 3 documents, and assuming that each 3 documents has only 1 sentences, right? If you want to create a bag of word, each row is actually representing your documents. So these are document 1, 2, 3. I have shaded off my stop words, right? High frequency words. So these are only the relevant words which I have. And then I have marked for each document whether that word exists or not. So it shows that for the first document here, we don't have the word actor, but we have grade and depends is 0 and so on and so on. So this is the most basic way of creating the bag of word. You have much advanced method of creating bag of word nowadays. You have TF-IDF, you have Specky, and there are a lot of libraries which are available. They actually represent your document in the vector form so that you can feed it in the model. As we said that we cannot feed the text itself, but these are the representation which can be fed into the model directly. Now, some of the methods which I want to talk about in the lexical processing. Now, suppose you are dealing with a text, right? We understand that we want to reduce the volume because the text itself are very huge and we want to reduce the volume. That's why we talked about eliminating the high frequency words and also the low frequency words, right? There are other methods also to reduce this. So here is this 2 methods which we will talk about. One is stemming and other is lemmatization. So when you say stemming, you can see there are words like warm, warmer, warming, and warmed. Actually, all these words actually mean the same, right? So instead of processing each of these words separately and then finding the meaning out of it, I can reduce all of these in a single token, which is warm, and then I understand it. So there are 2 ways by which you can reduce the word to its base form. One is stemming, and we will see lemmatization in the next slide. So when you do stemming is based on the rules like this. Okay, so it takes each of the words. They are rule based, which works on the suffix of the words. So these rules are actually applied on the suffix of the word. It says that if the word ends with SSES, these are just examples. You convert it to SS, and if it ends with IS, you end it I, and so on. Okay. But you can see that when the stemming works, it actually creates some error. So that's why you have TIES, and according to rule, it has been reduced to TI. Actually, it is a wrong spelling, right? So because of the lookups which we have, because of the rules which we have defined, you can end up creating junk also in stemming. The next method here is about lemmatizing. Lemmatizing again does the same thing. You have different forms of the word, try to reduce it to a root word. But unlike stemming, this is a dictionary lookups. Okay, so it looks up for the base word in the dictionary and then try to do it. And because it is a dictionary lookup for each of the word which you have, that's why it is more time consuming. So lemmatization for sure is more time consuming than stemming, but it never generates a junk, because you have dictionary lookups and the root words are already been noted, right? So never generate a junk as we have in stemming. Now, a few of the things which I want to talk here is about why NLP is hard. When I say hard, it doesn't mean that it is hard because we can't do it. It is hard because we have to take extra steps or extra precautions when we are implementing it in a model. So first one here is about the ambiguity. We talked about words like bank and even a duck. You have different words which can mean different things in different contexts, and you have to be like, as a human, we understand that these words mean different in different sentences. We have to enable our model to handle this ambiguity. Also, we talked about tokenization, and we saw that we break it into the small chunks and then we try to understand it. But there are languages where the tokenization itself is very difficult. So if you can see, there are various languages where you have different type. Even Kannada we all are in Karnataka here and we speak Kannada. Kannada, if you not only Kannada, if you talk about Hindi or Sanskrit, we have something called Sandhi, right? So when you do Sandhi, actually a lot of words combine together and they form a single one. So if you try doing tokenizing on any of the Hindi text or any Sanskrit text, it takes a lot of effort because they actually get combined together, unlike English, right? So we have to do some extra processing to do those tokenization. Unknown representation is something which is not known, and then you have to supply different meaning. Like we took example of PM and Prime Minister, right? So those are representations which are very obvious as for us as a human, but for the model to understand it, we have to supply extra information. Expressibility, again, when we talk about lexical processing, we say that we break it into small words and we try to understand it. Here is an example where you have two different sentences. Actually, they both mean the same. As a human, we understand it. But can you make your model also understand it? Because there is none of the text which is common in that, right? So even the vocabulary is very different. So how will you make your model understand that these are actually meaning the same? Unmodeled variables. You have, when you talk about like rat and elephant, you know that rat is a very small animal and elephant is a very huge animal. You can visualize it in your mind. Can you make your model also understand that? That is some extra work for us. And sparsity, we already saw that most of the documents which we have, the high frequency words which we have are actually irrelevant words. They are the stop words. And that's why when you want to process those documents, you have to actually get rid of those stop words before you start doing any kind of processing into it. So that's all I have for today's presentation. And I'd like to have some questions if you have for me. Please feel free to ask me any questions.
Yeah, thank you, Ms. Supriya. Okay, it was a very insightful session and you explained like what are all the process that happens in NLP, like tokenization, bag of words, stemming, lemmatization, everything you have explained very nicely. And we have some questions from our students. This is okay related to your job role actually. So how is data science used in finance and accounting?
Okay, I'll give you my background, how I stepped into data science. Stepping in data science is a very like long time back in 2013 when I was hired for ANZ. We have a lot of there was no clear word that time. The word data science has already been in the industry. We have AI also from a long time, but there were no roles as such data science. We had data analytics from a long time in the industry, but we don't have data science as such. So when I landed up, there were a lot of remediation project that the bank was doing, and they wanted to remediate some money back to their customer because they have been fined differently. And that's why they want some people who can understand their data. They can figure out what has gone wrong with the transaction and then to remediate it. So that's how I entered into analytics, and I stepped into talking about the kind of work which I'm doing now. Currently, I'm working in KYC and client onboarding for JPMC, and most of my work are aligned to anti-money laundering, or there are due diligence or client onboarding or KYC. We do a lot of machine learning models, lot of NLP models related to the corporate banking. We are aligned to more of the KYC in the corporate banking. I belong to corporate banking, so a lot of sentiment analysis also reading which we do, and chatbots which are aligned to KYC and client onboarding. That is one thing. Talking over my previous role in Levi's, there were very interesting projects which we were doing in Levi's, like recommendation system. So you might have seen when we all see Netflix or Amazon Prime. So as soon as you click on one movie, it starts showing you that these is also you will like. Those are actually the recommendations which it makes, right? And those recommendations are very common in any of the retail platform. So I was working on a recommendation system of the Levi's, where we had Levi's.in India platform, and based on what the customer is purchasing or what is their previous history, and also based on the products which you have, right? We have to recommend a right product to that customer. That was one model which I did. Again, there were models for price and promotions, where you have festival season coming up, right? Suppose you have Ganesh Chaturthi coming up, and most of the Levi's business are, for that matter, also on franchisee, right? So we have Myntra as a platform or Flipkart as a platform, and they launch sale, right? So the same sale cannot be launched for all the customer, and you want the promotions or the sales to be very much aligned to the specific customer. So it requires a lot of understanding of your customer base. So you do the CRM first, you do the customer segmentation first, where you actually classify your customers into different brackets. Based on the different brackets of the customer which you have classified, you launch different type of promotions. And how the promotion go, how will you launch those, and then how will you target those customer, make sure that the customer actually goes through those promotions, and then they actually get benefit out of it. Those were some of the projects which I was doing in Levi's.
Okay, thank you. And one more question. So how important it is in a company like JP Morgan, and how much knowledge on finance one must have in order to be a data scientist in fintech based company?
Okay, that is a very good question. Actually, see, when you talk about different domain, right? Different domain are at different levels. And specifically talking in data science, it's a very evolving field. We have a lot of researches going on in data science also. We have white papers, and there are a lot of researches. You go through one model and the other model comes up, right? So actually, when you are implementing one model, it might look irrelevant because something new might have come up, and it's a very evolving field. But unlike the other domains, banking sector is still one step back. We are not that evolved. So that's why most of the projects which we have are mainly not on deep learning. We use deep learning mainly specifically on the text, but because we don't have much of the data specifically as text, other than text like images or videos, I think deep learning is not very relevant. So most of the processing which I do are more aligned. I think I have been doing, this is my own personal experience. So most of my projects are more aligned to natural language processing, which we do. We do use deep learning, but again, as I said, specific to our text. And that's why those models, we don't use high-end models of, and also the processing kind of thing, right? As I said, as and when you advance in the deep learning, you require better processing, better storage, better GPU. You can't process it on your own CPU. So those kind of models are not relevant in the finance sector. We still have very basic setup. Also, it's a very evolving field. So we are learning. I'll say most of the domain are much ahead than the banking, and we are one step back. Okay, we are just paving our road on the similar lines.
Okay. Okay, thank you, Ms. Supriya. Our director, sir, with us. Sir, do you have any questions? Let me check. Sir, do you have any questions? Okay.
I wish all the best to all the students, and thank you for being with me today evening.
And just okay.
Hello, thank you, Supriya. I'm just traveling to airport, so sorry about that. Thank you so much. I listened to this entire session. It was very informative, and we look forward to work with you. And
thank you, sir.
Srija will be your point of contact for you.
Surely.
Thank you.
Thank you. Thank you, sir. Thank you, Dr. Srija.
Yeah, thank you. Thank you, Ms.
Bye-bye.
So now we are at the end of our session. Okay, I like to thank all my supporters, and first of all, I'm thankful to our director for giving me this opportunity to organize this event. And next, I thank all our distinguished speakers for making this event very fruitful. And I thank my colleagues and staff who helped me to organize this event without any hassle. And finally, I thank all the students. And without them, this event would not be a successful one. Okay, thank you all. Now let's rise for national anthem.
Okay, also good. Thank you, Srija, for doing a wonderful job of putting together this workshop. I think on behalf of all of students and the colleagues, I appreciate and thank you for the efforts.
Thank you, sir. Thank you so much.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Yeah, thank you, everyone. Okay, I'll close the session. Thank you.